Okay, today we're going to talk about parallel circuits. Now, previously we talked about series circuits where everything can be written as basically a single loop. Well, a parallel circuit is something that isn't going to have just a single loop, but could be written as one. It could be written as a loop with several different branches. So literally, I could choose one, two, or three different branches, and we're going to have different resistors and whatever our voltage is. Now, there's a couple things that we're going to do with this. Now, one of the important skills that we're going to remember or that we need to know is how do we calculate the resistance for all of this? Now, there's two different ways that we're going to do this. And the first way is, and one way is with our uh, a resistance formula, and it's that the reciprocal of the total resistance is equal to the sum of the reciprocals of the resistances. So this is why it's important to remember now how to treat some or how to deal with some fractions. Now, when you're done adding these, what you're going to do is just take the reciprocal of the result and you'll be fine. So say I have something like, say I have a circuit like this. Okay, say I've got a circuit where I've got, oh, I don't know, just making this up as I go. Let's say I've got something with, say, 2 ohms and 4 ohms and then 6 ohms. My total resistance, 1 over that total resistance is going to be 1 over 2 plus 1 over 4 plus 1 over 6. So I would need to find a common denominator here. And a common denominator between all of these things, well, between 2 and 4 it would be 4, but between 4 and 6 it would be 12. So I'm going to convert all of these to twelfths. This would be, I'll multiply that by, say, 2 over 2. This one would be times 3 over 3. I'd multiply this one by, say, 6 over 6. Here I'd end up with 6 twelfths plus 3 twelfths plus 2 twelfths. That's going to be 9, 10, 11. That'll be 11 twelfths is the reciprocal of my total resistance. So that means that my total resistance is going to be 12 over 11 ohms, which comes out to be something along the lines of, now let's see here, 12 divided by 11 is, about 1.09. It's and 1.090909 repeating, but let's just call it 1.09 ohms. Okay, that's one way of doing this. And honestly, this formula it might be inconvenient to use, but it's still something that we can go ahead and use, and it's going to be important for us later on when we talk about combination circuits. So let's let's figure out, let's go over another way of doing that, and that's figuring out the let's figure out what our current in each branch is. So we have a current method, kind of our current in each branch. Because essentially what's happening is when I've got this, I could say, oh, well, electrons could flow across this, and let's say that's 6 ohms there, but it could also flow across this, and we said that was, oops, I said that was 4 ohms, or it could flow, across our third branch, which we said was at about 2 ohms. So what we could do is, and let's say I've got a total voltage of, say, like 24. Actually, you know what? I'm going to call it, yeah, I'll call it 24 volts. So here I'll call this, branch 1, because here I've got, resistance 1, resistance 2, resistance 3. So my current 1 would be, well, V is equal to my IR. In this case, I'm just figuring out what this current is. So here I'm going to have my voltage. So this is going to be that voltage over that resistance is equal to that current. So here I'm going to have 24 divided by 2. 24 divided by 2 is going to be 12 amps. Okay. Okay, in that second one, 24 divided by this voltage divided by that 4. Okay, I'll have less current going through there. It'll be 24 divided by 4, which is 6 amps. Or I'd have even more resistance in this last one. 24 divided by 6 would be 4 amps. So here I've got the current in each branch. So if I were to figure out how much power was flowing, or what the electron flow across all of those would be, it would be 12 amps from here to here, or 6 amps from here to here, or 4 amps from here to here. But if I were to look at what was going through this entire thing here, I would say my current, the total current, is going to be all of those things together: I1 plus I2 plus I3. And in this case, it would be, that 6, or sorry, and I'd have my 12 amps plus my 6 amps plus my 4 amps. That would be, 22 amps is my total current. And using this same thing, using our same sort of idea here, remember, we've got, using our Ohm's law, we have, voltage is equal to current times our resistance. If I wanted to figure out what our total resistance is, I could say, oh, my voltage divided by my current is equal to my resistance. So if I wanted to find our total resistance here, I could just as easily take that voltage divided by our current, or by our total current. So in this case, remember, we had, so if I say that, okay, my total resistance is equal to that voltage divided by our total current, then I would say, okay, that's 24 volts divided by my 22 amps. And that's going to be, oh gosh, 12 over 11, which ought to look really, really familiar. 1.09 repeating for that total resistance. So there's a couple different paths of doing this, and as you see, it actually comes out to be the same as we had before. So when we're figuring out our total, there's two different ways of figuring out what your total resistance is. We can either we can either find the resistance with our resistance formula, which was, that total the reciprocal of the total resistance is equal to the sum of the individual resistors. Or we could find the individual currents from there. We could find the total currents and then after that you can use Ohm's law. So remember that total resistance is going to be equal to voltage divided by that total current. So we've got a couple good formulas for us to use. Hopefully this helps, and we will see you in the next video.